Okay, recapping from the first video, number 4 problem was Gina jogged 6 miles an hour for 30 minutes. How far did she go? And we talked about how since we're looking at our rate in miles per hour, we need to change 30 minutes to a half an hour or 0.5 hours. Our formula is distance equals rate times time. So substituting in for rate, we put 6 miles per hour. We're going to multiply that by our time, which is 5 hours. Notice that the hours cancel out, so our answer should be in miles, which is what we want. And so when we multiply, we get 3 miles. Okay, so next we're going to do some problems that are a little more complicated, and I'm going to pause the video and erase everything and be right back with you. Okay, you have to know that the first problems, the first examples that I gave you were easy enough to understand. I feel confident that both of you know how to do those kinds of problems. But of course the book is going to get a little bit more complicated. So I want to show you a way of doing distance problems that is much easier than how it's done in the book. Keep in mind, and I apologize for the messiness of it, I don't have a good control over my stylus yet because I have not been practicing with it. I'm going to make a chart. Distance, my chart should say rate. Hope you can see that that's an R. Times time equals distance. And I'm going to make some boxes. When you're doing these problems, such as the one that I'm about to tell you about, setting up a box like this is really important. So I'm about to read you a word problem, and I know it's a little bit harder because you can't read along with me. So I'll do this one example and then I'll pick up an example out of the book. My first example is Isaac and Ethan were driving out to Pittsburgh. Alright, first thing I want to do is I want to make an I for Isaac and an E for Ethan. Isaac took the Pennsylvania Turnpike and averaged 50 miles an hour, while Ethan took the scenic Route 30 and averaged 10 miles an hour less than Isaac. So let's talk about their rates. It says Isaac averaged 50 miles an hour, so I'm going to put in a 50 here. And Ethan averaged 10 miles an hour less, so that means that Ethan was going 40 miles an hour. If they both left at 10 a.m., and Isaac arrived at his grandparents at 4, when did Ethan arrive? Okay, listen to that again. They both left at 10 a.m., and Isaac, he's the one going faster, arrived at 4 p.m. That means that it took him, 4 p.m. is when he arrived, he left at 10 a.m., so it took him 6 hours. And we don't know what Ethan's time is, so I'm going to put an X here for Ethan. Now, the book doesn't state this, and it should, but if the book doesn't say so, you need to know that the distance is the same. So the distance for Isaac and the distance for Ethan are going to be equal to each other. So we can set up an equation for that. Ethan is 50 times 6, and that will give us Ethan's distance. And Isaac drove the same distance, he just took a scenic route and went slower, so he is 40 times x. All right, so 50 times 6 is 300. Equals 40x. And you all know how to get rid of the 40 because we need to get x by itself. X is going to give us Ethan's time. So I divide both sides by 40. And I get 7.5 equals x. So the answer the question was, when did Ethan arrive? And it took him 7.5 hours. So 10 a.m. plus 7.5 hours gets him there at 5:30